Good afternoon, everybody. Welcome along to our session on bar modelling, which we hope will be a practical guide for teachers. I have to give credit to a lot of the work on these slides to my colleague Becky, who unfortunately has been struck down without a voice this afternoon. So you're going to have to just hear from me. But Becky's here to make sure that I say everything that I'm supposed to say, and possibly glare at me if I do not. My name's John Cripwell. I am the National Education Lead for Primary Maths here at Twinkl, and I get to work with a wonderful maths team, which includes Becky, who is one of our educational content leads for primary maths, and has years of experience teaching in primary schools, and also working on the educational content side here at Twinkl. For myself, I've been working in education for about 18 years. I had about 11 years as a maths lead at a primary school, worked as assistant head as well, and a teaching for mastery primary specialist too. So I've been sort of living and breathing maths and primary maths for quite a few years now. And I recall my first sort of run-in with bar models and being a little bit unsure of them, and how they could be used. But I would say that by the time I finished teaching, which was only earlier this year, then I was using them in pretty much every lesson. They really are incredibly versatile, fantastically useful, and brilliant for unlocking the structure of the maths behind any maths problems and any maths questions. So let's get started. Hopefully by the end of this session, we will have uncovered what a bar model is, and where it came from, why we should be using bar models, and how it can support mathematical understanding particularly. We will tackle some myths, common misconceptions and mistakes that sometimes happen with the use of bar models. We'll also consider different types of bar models, and how to use each one of them most effectively for different scenarios. And we will consider what progression in bar modeling might look like, and how the bar model relates to other mathematical structures as well. So what is the bar model? Well, it originated in Singapore in the 1980s, when all the best things were developed, and it was developed by the Ministry of Education and integrated into the curriculum over there. And obviously Singapore is one of the sort of jurisdictions internationally that we have taken a lot of inspiration from, I would say, when we've been developing a mastery approach in this country, in England, and one of the areas that we look to, because they were fundamental, I would say, in leading the way with conceptual understanding, and deeper understanding of mathematical structures for their pupils. And in Singapore, it is still considered a key aspect of teaching for mastery approach. And I would say it's become fairly well integrated into many of the schemes that we use over here now in England, but not necessarily always effectively, which is one of the things that we're going to talk about this afternoon. It's based on the work of Jerome Bruner, who you might remember from your university studies if you did anything with education at university, and his 3 modes of representation: enactive, iconic, and symbolic, of course. But that led basically to the framework of the concrete, pictorial, and abstract approach, where we're encouraging learners to explore with concrete materials, with manipulatives, get hands-on, really see for themselves and get a feel literally for how the maths works, and then moving to a pictorial approach, a pictorial representation perhaps of those concrete materials. And those pictorial representations also have a progression within them and become more abstract as we move through them. And I would suggest that a bar model, certainly, as we will see, can be represented in a concrete manner, but sometimes as we move through the progression of bar modeling, it can become a little bit more abstract as well. And then finally moving into the abstract, which would typically be more of a formal method, based upon the pictorial and concrete representations that the children have encountered before. So the bar model, as it says here, is a visual representation of a calculation or a problem that uses proportional bars to reveal its structure. And I would suggest that the proportionality of the bars is one of the things that is possibly a bit of a common misconception or mistake that is made, and we'll explore why that proportionality is really key and really important as we go through the session. So why should we be using the bar model? I've probably already touched on a little bit of this, but it bridges the gap between concrete and abstract by helping pupils to see the structure, particularly in tricky domains such as fractions and ratio, which are by their nature much more abstract than, say, addition or multiplication or subtraction, where we can see things being taken away or added much more easily. Fractions are one of those things that can become can remain a little bit of a mystery, really. And I would suggest that bar models are one way to help pupils really see what's happening in the maths with their use alongside fractions and ratio. Bar models also support a deep conceptual understanding rather than relying on tricks or rote memorization. Certainly when I was at school in the 1980s, my teachers relied quite heavily on rote memorization, which was a bit of a problem for me because I was rubbish at memorizing things that I wasn't deeply interested in, and I wasn't deeply interested in maths at the time, certainly not as I am now. So we know that just relying on procedural understanding and asking children to memorize things isn't an effective way to help them to learn maths at a deeper level. But bar models are one way that we can help them to understand conceptually what's happening. And when we talk about conceptual understanding, we're talking about really understanding the structure of the maths that's happening underneath the problem. So, what's really happening when we multiply one fraction by another fraction. To understand what 1/4 times 1/4 mean, to understand actually what's happening with 1/4 times 1/4, if we understand that multiplication is repeated addition and we're just looking for a quarter of a quarter or quarter lots of a quarter, that makes things much easier to understand. And helps us to know what to do if we're not sure what to do, which is the key to maths, I would suggest. Bar models are very much aligned with a teaching for mastery approach, and they can also support pattern spotting and making connections both within and across different topics. And again, the interconnectedness of maths was not something I appreciated when I was at school. I kept thinking that everything was just another thing to learn in isolation. But if we can help children and learners to see that actually maths is connected, and so that, just because we're doing addition this week doesn't mean that subtraction isn't also necessarily important, or we might not be touching on multiplication as well, then if we can help them to see that things are not siloed in that way, then it can really help them with problem solving and reasoning and mathematical thinking. It's also been shown to support oracy because it opens the door for lots of rich conversations about what's happening and why, and it can help develop reasoning skills by helping pupils to explain their thinking if they don't yet have the vocabulary to do that out loud. And we know that it aids problem solving. We will certainly go through that in some detail as we go through this session. So using an empty bar model, a really effective way to introduce and explore its usefulness as a representation. And bar models should be used alongside concrete and abstract representations as well as other mathematical structures. I think that's a really key point, actually, that sometimes when we're thinking about the concrete pictorial abstract approach, we think that we always start with the concrete, then we move separately into the pictorial, and then the abstract is the end goal that we want all children to be able to do. But actually, we know from research and from experience that there should be some movement backwards and forwards along that continuum of concrete, pictorial, and abstract. And actually, children often need to see the concrete and the pictorial next to each other so that they can understand the link between the two of them. And also the pictorial, next to the abstract, and the concrete next to the abstract as well, so that we can really understand what's happening. Too often in maths, I think things like numbers that are just thrown out there appear to some children to be plucked out of thin air and can be quite difficult to understand where those numbers have come from. But using an effective CPA approach can help all learners to understand where those numbers have come from, the importance of them, and to help them to replicate that in their own problem solving. So, common myths, mistakes, and misconceptions for pupils. So these are things that pupils might be thinking about bar modeling, and things that you might hear them say when you're working with them. And definitely this first one is a fairly common one. I would suggest there are often a subset of pupils in a class who can just feel that they just know the answer, and therefore they don't need to represent a calculation or a problem with a bar model if they can already solve it. And that sort of makes sense on one level, doesn't it? If all we value in a maths lesson is finding the answer, then there's no point in having a bar model, is there? My argument would be, and I think Becky's argument when she put this particular slide together, is that it's not just about maths shouldn't just be about a focus purely on finding the answer. When we talk about what makes a good mathematician, most people, if you ask them, will focus on qualities and traits like resilience, problem solving, mathematical thinking, curiosity, ability to think around a problem. And very few people, when you ask them that same question, talk about being able to do quick mental calculations. We know that that can be helpful and important. I'm not dismissing that as a skill, but I think if we can look beyond just trying to reward the person who gets the answer fastest, and we know that that can be undermined slightly by the assessments that children have to do at school, unfortunately. But if we are trying to build a well-rounded mathematician, I think that we need to look beyond just getting to the answer fastest and rewarding those children who get the answer fastest. By encouraging them to use a pictorial representation, such as a bar model or concrete apparatus, we're encouraging children to think about things in a different way, and to really dig underneath the surface level understanding that they might have, and begin to explore the structure of the maths underneath, which will make other areas of maths much easier for them as they begin to explore those things. It was interesting. Quite a few of the people, I should say myself and Becky, we have a podcast called the Primary Maths Podcast. Every week we interview people who are experts in their fields around maths or education. And so many of them who enjoyed maths at primary school suddenly found that they had a much harder time at secondary school, or even if they enjoyed it at secondary school, suddenly had a much harder time when it came to A-level maths, because they had quite a surface level understanding of the mathematical structures that they're dealing with. They were able to quickly calculate things, quickly find an answer, but they didn't necessarily have that deep understanding of what was happening with the maths. So that's what we want to encourage, and bar models and encouraging children to represent their thinking is a key way to help them to do that. If I can represent a calculation or problem in a bar model, it will solve the problem for me. That's another key misconception, not just for pupils, I think sometimes for adults as well, working with children. We sometimes come to see concrete manipulatives and pictorial representations as a method for solving maths problems, but they're not actually a method at all. Certainly they shouldn't be one, and if we rely on them to be a method, then they will end up being a crutch that children have to rely on. And it's possibly one of the reasons why in some schools you will see typically prior lower attaining pupils being the ones who are given the manipulatives and encouraged to draw the pictures and things, and prior higher attaining pupils not using those things, unfortunately. we need to, as educators, understand the purpose of these representations, whether they're concrete or pictorial, and make sure that they are fulfilling the purpose that they were designed for, which is to expose the structure of the maths and really explain what's going on underneath. And as you'll see, as we go through some of the examples of bar models in this session, you'll see how the right bar model can really expose what's happening in a mathematical problem. But they're not a method to solve it. We should have more efficient methods than that. The purpose of them is to help us to understand which method might help us to solve it. All bar models have one big bar at the top and a bar split into sections underneath. If this was an always, sometimes, never problem, this would be a sometimes answer, I would suggest. We will have a look at lots of different structures for bar models over the next few slides, and hopefully put that particular myth to bed. The same with this. I can use the same template every time I need a bar model. Lots of different templates, lots of different structures, and we need to make sure that children have been exposed to all of them, I would suggest. And I have to draw a bar model every time I solve a maths word problem. Probably the opposite of the first one that we looked at here. As I was saying before, ultimately we want to move away from having to use a bar model every time that we're solving a word problem. If it's a structure that we're familiar with and we're confident that we know what we're doing, then we don't necessarily have to use one. That's different from saying I never have to draw one because I just know the answer. There's a slight tension between those two things, I might suggest. But ultimately, what we want pupils to see is that a bar model is a tool to support understanding and help them to talk confidently to their peers and to the adults in the room about their maths. And that's really the function of an effective bar model. So, some common myths, mistakes, and misconceptions that we might hear from teachers. I think we've probably covered this, but my pupils already know how to use bar models, so I don't need to teach it again. What I would tie in with this is when we're thinking about a child's journey through school, they might be introduced to bar models even in year one, even in reception, potentially. Fairly simple structures for looking at how numbers can be manipulated, put together, broken apart. The bar models themselves will become more complex as a child moves through school, and it's really important that teachers are modeling each of these as they go along, recapping the purposes of them as we go. Some of my pupils don't need to understand or use bar models because they can already use abstract methods. I think we've probably covered that one, to be fair. But again, the purpose of it isn't to replace an abstract method, it's to help explain our thinking. Bar modeling makes the maths more confusing for my class, so I don't use it often enough. I would suggest that this happens when bar modeling isn't used consistently and it's brought out. I'm glad to see Becky nodding now. I've got the right end of the stick here. That's good. If we're only dipping into bar modeling every so often, it isn't going to be a structure that pupils are familiar with, and therefore it will be confusing if we're only using it now and again. And again, I was talking to somebody earlier on the podcast this week, and we were talking about when sometimes we might use too many variations of a representation in one lesson, and it can become variety rather than variation. And that, I think, is often where it can become confusing for pupils as well. So making sure that there's a progression through school, as we'll talk about later, in how bar models are used, will mitigate any confusion, I would suggest, that pupils might have. When they're familiar with the structure and they know how it works, it's something that they see regularly. I don't think there'll be much room for confusion then. Bar modeling is the only tool my pupils need to problem solve effectively. We know that there are a huge range of different mathematical habits that pupils need in order to solve problems. Bar modeling is one of the tools that they might draw on, but it's certainly not the only one. And bar modeling takes too long and uses valuable lesson time, which we don't have. I'm feeling that there's a year 6 teacher shouting that at me at the moment. As a year 6 teacher who spent much, or as a teacher who spent much of his career in year 6, I can empathise with the lack of time. I know that's not just a year 6 thing; it's all across school. But I would just go back to what do we value in the maths lesson. If it is just finding the answer and we want the quickest way to find the answer, then we can trying to teach procedures. We know that that doesn't work. We know that children aren't successful in learning maths that way. So we need to, look at a different way of doing things. So different types of bar models. One of the earliest ones I think pupils are probably exposed to is this part-whole relationship model. We see the part-whole relationship model not just in bar models. That there is obviously the part-whole model as well, which some schemes use and some schools use. A bar model is another different way of representing that same idea. So this is probably the most typical sort of bar model that we're used to seeing, which is the bigger bar on the top, as we've said before, and then 2 or more bars underneath to represent the different parts of that whole. So the top bar representing the whole, and then the different parts underneath. Note that the use of color in some of these as well, which is really important. And if we can replicate those colors into any abstract work that we're doing as well, so that children can see where these numbers are coming from and going to. And by that I mean, if I was working on this part of the 20 over here, and I was writing that on the board, I'd be writing 20 in purple if my school budget sprang to different colored pens, and I would be possibly, if this was if we were doing addition here, I'd have my 5 written in green, my 15 written in orange, and then the sum written in purple, so that children can really see quite clearly where these numbers are coming from. And that's a really important aspect to all of this. We can use bar models as well with abstract things as well, such as counting different symbols to make a total of 7 here. We can also use bar models to look at all the relationships here. So in this particular example, we could say that 7 plus 3 equals 10. We can also see from here that 3 plus 7 also equals 10. We can see that 10 take away 7 equals 3. We can see that 10 take away 3 equals 7. So we're looking at every part of the part-whole relationship here as well. We can use bar models for missing number problems too. I would suggest that this is conceptually quite abstract for children, even though it's very simple maths. Some children can be confused when we're looking at this, because essentially it's an addition problem that requires subtraction, doesn't it, to be able to solve it. And just to work out what to do can be tricky. This is where a bar model can really help, because we can put in we know the total is 6, and then I can find what the other missing part is, and it just clarifies what needs to be done in order to solve the problem. Excuse me. I haven't been anywhere near 200 miles of Becky, but I seem to be losing my voice as well. We'll see if I can make it through the rest of the session. As I was saying before, we can use concrete materials up here, and this is a visual representation of how we might use concrete materials to support this. Using just cubes and blocks, multi-link blocks, to do the same thing, to really expose those part-whole structures. And again, the use of color is really important here as well. It's not accidental. This has been chosen to make things even clearer for pupils. So this particular type of bar model can be used to represent aggregation problems. If you have been on any Teaching for Mastery work groups or anything like that, you might be familiar with the models of addition, aggregation, and augmentation. Aggregation is where two quantities, are put together to find the sum. Augmentation is where a quantity is increased. Do pupils need to know the names of both of those different types of addition structure? Not necessarily, but I think as a teacher it's useful to know those two structures exist, so that you know which bar models can help you to model those effectively. But here it's exposed to, but we can see the two quantities that we've got here, 12 and 8, and what we're looking for is the total. And again, this isn't a method, it's just showing what might be happening in the problem. And we'll look at some word problems later just to see how this might line up. For subtraction, we can use a part-whole bar model to represent subtraction by taking away one part to identify a missing part. So we know that we're starting with 20. We know that we're taking away 12, and we know that there will be a missing part here that we can find by doing 20 take away 12. Just notice in the construction of this bar, the 12 is greater than the missing part here, and I would be constructing this with children. I'm personally more of a fan of, where possible, constructing bar models on a board or on a flip chart so they can go on your working wall, rather than just presenting them already constructed on a screen on a PowerPoint. The reason for that is that children need to see how these things are constructed. It gives you as a teacher or teaching assistant opportunity to explain your thinking, explain where these numbers are coming from, and talk through it. And it's not just pressing a button and it magically appearing before their eyes. If we want children to be able to draw these things themselves, they need to see it being drawn. So I'm a strong advocate for flip charts and constructing it with children. I think it's absolutely fine to have some parts of it constructed first. Here's one that I made earlier, but certainly filling it in yourself. And I would say here, this idea of, why is the 12 bigger? Where am I going to make the line between the 12 and the other part? Gives us opportunity to talk about, well, I know that 12 is more than half of 20, so it's going to be the bigger part of the two parts of this whole. So it just gives opportunity to explore that structure a little bit more effectively, I would suggest. A couple, just expanding that over here, we can see it in different ways. All of these models show the same sort of idea, really. This comparison bar model here can help us to see the difference between two values, between 20 and 12, this missing part here. Bar models are also really effective to expose multiplicative relationships. And particularly, I would suggest the idea of seeing multiplication as repeated addition is really important within maths, and I think bar models are an effective way of showing that. So this representation here shows 4 times 6, or 6 times 4, and we can see what we would need to do if we didn't know our 6 times tables or our 4 times tables in order to find the problem here. So again, find the product here. So again, bar models are just a way of, or one way of, finding out what to do if you're not sure what to do, if that makes sense. I know that I've got 4 lots of 6. What does that look like? I can picture that in my head. Eventually, obviously, we want this structure to be internalized in a pupil's mind so that they can see it for themselves without having to draw it out every time. And that's how we build conceptual understanding, I would suggest, or one of the ways that we build conceptual understanding. We can do this with counters as well. We can place the counters into the parts to make sure that we're understanding the part-part-whole relationship, and it can help us to show the difference between 2 times 5 and 5 times 2, because it's important that we see that although the product might remain the same, actually structurally 2 times 5 is different from 5 times 2. And that's important when it comes to understanding contextually answers to problems. So fractions. I love bar models for fractions. I think, as I said earlier, it's one of the best ways of exposing what's really happening within fractions when we're looking at it. So here we can see another comparison model for a bar model for fractions here, and on the top we've got 3/4 or 1/4 potentially. Here again, this is where it's really important. The proportionality needs to be correct, and this is one of the things I think when you're working with squares are really helpful often for fraction bar models. Sometimes, if we just go back on the PowerPoint, something like this, sometimes squares can be a hindrance because we're having to work out, some children will want to do 20 squares to represent the 20 on the top and 12 squares to represent the 12 on the bottom, and it can be you end up needing enormous maths books to try and fit that on the page. Some plain paper can be really helpful here. We don't have to be exactly accurate with our models. It's just a representation. So again, just if I'm drawing this, I might draw this on plain paper, and just make sure that my 12 was slightly more than halfway along the whatever I've allowed for the 20. When it comes to fractions, though, the squares can be really helpful because they can make sure that things line up nicely. And so, again, for this comparative model here, we're comparing quarters with eighths. And I can see that if I've got 1/4 here, my 2 bars are the same length. That's really important because we're talking about the same amount, just split into different divisions, into different fractional amounts. And I can see here that 1/4 shaded up here is exactly the same as 2/8. And I've done that because this bar here has been split into 4 equal pieces to represent 4/4, and this bar here, which is the same length as I say, has been split into 8 equal pieces to represent eighths. And so that makes this, again, equivalence in fractions really easy to show. And again, it's a little bit like a fraction wall, isn't it? We can see just at a glance. I don't need to do any calculations. I don't need to do anything else. I can just see by looking that 1/4 is the same as 2/8. Here's a nice example of where a bar model can be used to support a word problem. So we've got George reading a book. The book has a nice round 200 pages, which is helpful. And George helpfully has read exactly 4/5 of the book. It's nice when we get numbers like this that have been chosen for the purpose of exposing the maths, isn't it? Rather than just random numbers that we used to get on some worksheets that made these sorts of things really tricky. Or worse, random numbers that I'd chosen for myself in a maths lesson and got partway through the calculation before I realised that I'd shot myself in the foot. So yeah, some forethought is appreciated here. So the question is, how many pages has George read, and how many pages does he still have to read? So if I was working with a pupil looking at this and we're thinking, how can I represent this? Because there's a lot of words here, there's a lot of numbers here. What do I need to do? We know that children who find problem solving tricky, they focus very much in on the numbers straight away and try to do something with the numbers. But understanding what we need to do here to find the answer is fundamentally important. So we would start with what we know. We know that we've got a book and it's got 200 pages. So I can represent the book here with a bar that's 200 pages. That shows our whole book at the top here, because what we're looking for is a proportion of that book that has been read. Again, this is one of those things that might be easier on plain paper, although you could do it on squares, but the squares require you to have some knowledge of what you're doing before you do it with the 4/5. We can then split up this 200 into 5 equal parts, because we're taking the 5 equal parts from our denominator here. We know that the word denominator denotes how many parts something has been split into. See Becky's episode of the Primary Maths podcast for a bit more on the etymology of numerator and denominator. But we can go into why those words mean those things. And we know that the numerator tells us that we have 4 of those parts read already. Now, looking at this model, it doesn't give us an answer. And we will get some children who look at this and say, well, I still don't know what the answer is. But again, we just need to be really clear on the purpose of the model. What this model has shown us is that we know that this is the bit that has been read. The 4/5 has been read. And we've got 1/5 that hasn't been read. The question is, how many pages has George read and how many pages does he still need to read? So this is just exposing what we need to do next, which is divide the 200 into the 5 equal parts. And then we can see the not read is 1 of those parts and the read is 4 of those parts. I hope that makes sense. Excuse me a moment. Just another example of a different problem down here. Oscar using a bar model and counters to find 2/5 of 15. Again, just a nice way of finding 2/5 by splitting our 15 up into 5 equal parts. And we can do that practically. We can draw it then pictorially, and then we can make the link to what the procedure was to actually do that in an abstract way as well. Bars are fundamentally king, I would say, of representations when it comes to exposing proportion and ratio. Again, the use of colour here is really important. Can't emphasise that enough, that colour can unlock children's understanding of what's actually happening with these abstract bar models. So here, ratio of oranges to kiwis is 2 to 3. If there are 6 oranges, how many kiwis will there be? Well, we know that in each group there are 2 oranges for every 3 kiwis. That's the bit that we need to teach, that we need to understand what this 2 to 3 means. And I can represent that with a bar. I could start with 1 bar and say, okay, we've got 1 group here of oranges and kiwis. For every 2 oranges, there are 3 kiwis. And I can draw that. How many oranges do I have in this group? I've got 2. Okay, so let's have another group with 2 more oranges. We've got 4 oranges now. We need another group with 2 more oranges. So now we've got 6 oranges. And again, the numbers here are kind, aren't they? But we can see why the answer to this problem will be 9 kiwis, really in a straightforward way, without really doing any calculations at all. At this point, we would want to link it to some calculations, but this is the structure that we're trying to impose and expose. And again, down here, 1 part of milk for every 5 parts of hot water. Rachel is clearly a very accurate person. She's making 600 milliliters of tea. How much hot water does she use? This sort of problem can be tricky because we're not sure if we're dividing by 5, or it doesn't mention 6 parts anywhere, does it? But just drawing it out to see this 1 part milk and 5 parts hot water shows us that actually there's 6 parts in total, and therefore we can divide the 600 by 6 which tells us that each part here is 100 milliliters. So she will use 500 milliliters of water. And again, I'm going through this at a fast pace. We will take this much more slowly if we were doing this with a class of children. But the just banging on about it again, I suppose. Really, the purpose isn't to just give me an answer here. The purpose is to find out what I'm supposed to do in order to find an answer. And then everybody's favorite, algebra, which looks like it might be moving places in the curriculum and assessment review. If we get a new curriculum in 2027, algebra might be one of the things that comes out of Key Stage 2 and is firmly placed into Key Stage 3. But for now, it is part of the primary curriculum. And I like a bit of algebra, so I'll be, I mean, I suppose you could argue that algebra, we're doing algebra all the way from year 1 when we're looking at missing number problems, to be honest. But when we're talking about algebra in terms of what we typically think of as algebra in the curriculum, this is the sort of problem that we might come across. And I would suggest that actually this sort of problem is the one that trips children up most, and adults actually, working out something like this, because it isn't immediately apparent how you would solve this without using something like a bar model. So in this problem, an adult ticket, helpfully, to a theme park costs £7 more than a child ticket. It costs £154 for 2 adults and 3 children to go to the theme park. In total, how much would it cost for 1 adult and 1 child to go to the theme park? So we know that we're looking for the price of 1 adult ticket, 1 child ticket, but how do we separate that, these 5 tickets here, from the £154? It doesn't look immediately clear. We can start by trying to think about what the £154 is made up from here with the proportional bar model that we've got here. And again, if you look carefully, we've represented that the adult ticket, we don't know how much the adult ticket is, but we do know that the 3 child tickets are the same amount as each other. The 2 adult tickets are the same amount as each other. And the adult ticket is just slightly more than the child ticket. And that's been represented in this bar here. So the 3 child tickets are the same size because they're the same value. The 2 adult tickets are the same size because they're the same value, but the adult tickets are slightly more than the child tickets. The next question is, okay, how much more is the adult ticket than the child ticket? Well, we can see here's the adult ticket. It's the value of the child ticket plus £7. And again, I think this is where you might lose children if we're not careful. We need to be going back to the problem here and just checking that that's right. The adult ticket costs £7 more than a child ticket. And this is where I think constructing the bar model for the children and alongside them, rather than just having it on the screen, is really important. So I'm going to draw out my adult ticket here. It's the same size as the adult ticket in the problem that we're looking at. We're trying to keep the proportion the same all the time. So the adult ticket here, I know that it's £7 more. So I've got my child ticket and then I've got £7 more, and that works out as the same price as 1 adult ticket. And then we can put that back together in the bar model below. So I've got a child ticket, plus £7, another child ticket plus £7. That's my 2 adult tickets, and then 3 child tickets. I think this goes on to the next. No, it doesn't. What we can see, though, that we've got here is the equivalent of 5 child tickets plus 2 lots of £7. So 5 child tickets plus £14. Hopefully what we can see then is if we take off the £14 from our £154, what we're left with is the price of 5 child tickets. So that's some quite complex maths there, mathematical understanding, but we've broken it down into simple steps to try and find our way through it. And again, I would argue that maths really is about trying to figure out what to do when you don't know what to do. And this is a great example of one way that bar models can help with that. And then multi-step problems, which we know are, typically a stumbling block for pupils. So here we've got some fractions mixed in. 6/8 of the vehicles on Joe's street are cars. If 24 vehicles are cars, how many vehicles are there in total? The bar model helps us here. We can start off with all of the vehicles in Joe's street. We know that he split them into eighths, so we need 8 equal parts up here to represent the vehicles. 6/8 are cars, so that's been split up here to show just the cars. This part here, the 2/8, we don't know what they are. They might be vans, they might be motorcycles. We'll be talking to the children about what they could be. I'm sure somebody will say something ludicrous like a plane. It's still a vehicle. Speedboat if they've been on Bullseye. And we've got 2/8 here that we don't know how many vehicles this is, but we do know that the 6/8 is 24 cars. Well, if we know 6/8 are 24, we can divide 24 by 6 to find out what 1/8 is. And again, that's conceptually tricky, and it doesn't do the problem solving for you, but it does help you to see why we're doing 24 divided by 6 to find 1/8, and then when we know 1/8, we can find the 2 missing 8s. So just when it comes to progression in bar modeling, I think it's really important that schools, where possible, can have not necessarily, you don't need a written policy, but if your scheme uses bar models, and you've agreed as a staff that bar models are going to be part of your approach to teaching maths, I think it's really important that we're clear what children have learned before and what they're going to learn next in terms of the bar modeling, so that we can make use of that in our maths lessons. In EYFS, bar models can certainly be introduced, and certainly into Key Stage 1 with simple part-whole models using concrete objects alongside drawn bars, which we've talked about and shown. In lower Key Stage 2, we might be looking at comparisons and change situations when we're thinking about money, multiplicative situations. And then in upper Key Stage 2 currently, I suppose we might introduce fractions in lower Key Stage 2, actually, to be fair, but certainly ratio, algebra and multi-step problems, more of an upper Key Stage 2 focus there. As we go through, the idea is to gradually remove the scaffold so that learners design their own bar models. I'm sure for anybody who has taught in Year 6, you felt the frustration of knowing that your children know all of these pictorial representations and then looking at their SATs paper in practice or at the end of the year and not seeing many of them being employed. Sometimes that's a good thing because the children have been able to move beyond having to draw them out, but I found it particularly frustrating where a question was unanswered and there was no attempt to use a bar model. I think that's more likely to happen when the bar models have always been constructed for them and children haven't had a chance to have a go at doing it themselves. So the goal here really is for them to have a bank of internalized bar model structures so that they can design their own bar models and call upon them when they need them in order to help them solve problems, or at least find a way to solve problems. It's also really important to regularly revisit earlier structures so that learners can recognize relationships across topics as well. We know that bar models link really nicely with number lines, with part-whole diagrams, and with arrays as well. I'd be careful about introducing all of those in one go, but certainly, you know, if children are familiar with a number line, there is no harm in making links between number lines and bar models when that's appropriate. Again, the beauty of constructing a model, any sort of pictorial representation with the children and for the children, and doing it as a class, is that you have the opportunity to talk about why you are doing it, and why you're making the decisions that you're making. And I would suggest that modeling of your thought processes are as important as the actually modeling of the bar itself. So when we're looking at a problem together, it's an opportunity to have a discussion. which bar model is going to be useful here? Is it even a bar model that's going to be most useful here, or would a number line be better? Where possible, try to use concrete resources to introduce the structure before moving to bars, and also show how the same situation can be represented in more than one way where possible. And for some children, I'd be challenging them to do that if they, have very quickly latched onto one way and can do it confidently one way. At that point, I'd be suggesting, is there another way of thinking around it? Not to be pedantic or to, try and confuse them, but because we know that when it comes to fluency, flexibility and adaptability is one of the key drivers of really fluent mathematicians. So we want children to be flexible and adaptable in their thinking and not rigid, because that makes the maths easier for them. And we want, our best mathematicians basically to do the easiest maths that they can. And so, not boxing themselves into one rigid procedure is an important part of that. Using STEM sentences alongside bar models can really support oracy and really develop that thinking. Again, the aim is to move away from using the STEM sentences, but to introduce a topic and to introduce a rule or a way of thinking, STEM sentences are a really helpful means to do that. And using them together as a class, and repeating them together, using them to instruct your partner on what to do next, and that sort of thing is really beneficial. So finally, some top tips for using bar models. Keep bars, I've said here, roughly proportional. Sometimes we want them to be exactly proportional. Other times it's okay to be roughly proportional, depending on the structure and what you're trying to show. But that proportionality is key, and we want to emphasize that every time that we're drawing bars. If we're breaking things down, we're often, one of the misconceptions that maybe we didn't mention earlier is children trying to do comparative bars but using different size bars and things. That can be a bit of an issue. So making sure that we're keeping the bars proportional so that they make visual sense. Keep the layout as simple as possible and avoid unnecessary decoration around the bars. I know we want slides to look engaging. If we're doing slides, we want them to look engaging and interesting, but if it's a pictorial representation, we want the focus to be on the representation, not on any superfluous things around it. So avoiding unnecessary decoration and focusing on the structure is important. Always label the bars. Pupils will definitely talk with more confidence when the labels are clear. We want to remove any mystery from the maths. That's the point and purpose of visual representations, and that's why I was talking about the different colors and things. We want to remove any mystery at all, and make it really, really clear where these numbers are coming from, what the numbers mean, and why the answer is the answer in that context. So labeling the bars means that if, we know learners sometimes drift off. I'm sure all of us here will have drifted off for a couple of minutes at some point during this presentation. If they've missed something, then at least the bars are labeled, and the presentation, the pictorial representation is labeled so that they can understand what each part of it means. Where possible, start with familiar context so that pupils focus on the structure and not the story. We see in maths, don't we, a lot, about purchasing watermelons and things like that. And sometimes we get quite ludicrous quantities of things as well that can take away from actually the maths, because we get hung up on how realistic something is. So it's just useful to start with familiar context, I think, and make sure that those things make sense. Importantly, encouraging children to explain why they chose that model. So that metacognition, thinking about why we're doing what we're doing, is really important. Anticipate misconceptions. For example, pupils may assume each part is always equal, and that's why that proportionality is really important as well. We need to show that they're not necessarily equal, except where they are equal. And that representation is really important. And finally, as I've already said, modeling, drawing bars on a flip chart or board rather than relying on pre-drawn models. Pre-drawn models are okay sometimes, where I would say that where we're already familiar with that structure and children already get it and know how it's been constructed, then it's fine to use a pre-drawn bar on a PowerPoint or whatever at that point. But as you're learning about the bar model, I would definitely be creating them alongside the children and with their input where possible as well. So that is the end of the presentation that pretty much Becky put together, and I have hopefully delivered in a way that she intended. Just a little plug for myself and Becky here at the end. If you want any more input on this sort of topic, we cover all these sorts of things on the Primary Maths podcast, which comes out with a couple of episodes a week and is highly listenable. Yeah, that's my little sales pitch for the Primary Maths podcast. Go and give us a listen, and you'll actually hear what Becky sounds like. Actually, if you listen to some of the other episodes, she does have a voice and a lot to say usually as well. So thank you very much for listening today.